Hello, good morning, guys. So in the last class, we discussed about what is a route, what is a routing table. Then we saw about type of routing protocols. We saw about administrative distance. We saw about static routing and default routing. So if we discuss what is a route, route is the best route, best path to reach from source to destination. This is the route, and the collection of route, that is your routing table. And what are the type of routing protocols? So if we consider about routing protocols, so we have a static routing, we have a default routing, and we have dynamic routing. Static and default, they are the same thing. Okay, why? Because in both of them, we have to manually specify route. We have to manually specify a route. But in static routing, you have to manually specify a route for each and every destination. And in case of default routing, you just specify one single route for all the destinations. Means in case of static route, your destination networks are known. Then only you can perform static routing. And here, the destination networks are known. If you don't know about the destination networks, you cannot perform static route. Then if you do not know about this, you can still configure default routing. Okay, so default routing is when destination networks are unknown. Doesn't matter how many destination networks are there. Like right now, your internet. Do we know how many networks are there? How many, what are their subnet mask and all this information? Do we know? We do not know. So what we have done, we just have configured one static route, means the default route towards the internet router. And what is happening? We are able to use the entire internet. We do not care about what are the different destination networks, what are their IPs, what is their network IDs, and what is their subnet masks. But still, we are able to use. Why? With the help of default route. Clear? Okay. So basically, what have been done, that a default route is configured towards the internet. That's it. Okay. So your default routing, it is a special case of your static routing only. If you see the configuration command, so in case of your static routing, you say IP route, then you say the network ID, then the subnet mask, and after that you say the next hop. Correct? This is the way you specify a static route. Just in case of default routing, this network part and subnet mask part, we tell that we do not know. So if we do the routing for each and every possible network, and how do we specify that? We say this is all zeros, means any network, any mask, and you give the next hop. This becomes your default route. And this is the reason the AD value of your static route is 1, as well as your default route is also 1. Because your default route is just static routing only, just a special case. Okay. Then we have the dynamic route. So in case of dynamic, what happens?
When we set the routing, then it will select its own best path to send the data to the destination.
In case of static, or what you're talking about?
Dynamic.
Okay. See what happens in the case of dynamic. First of all, your dynamic has been divided into certain categories. Okay. Major 2 categories. One is the IGP and one is the EGP. Your IGP stands for Interior Gateway Protocol, and EGP stands for Exterior Gateway Protocol. So if you want communication between the same AS in one branch, you can simply understand, then you will be using the IGP protocols. Okay. If you want communication between different AS, then we'll be going with the EGP protocols. Now, again, your IGP has been divided into 3 categories. One is your distance vector. Second is your link state. And third is your hybrid. Your distance vector protocols, these protocols mainly focus on the distance. These mainly focus on the distance between source and destination. Okay. So how do they calculate the distance? By comparing the number of hops, or you can say number of routers. See, if you take an example, this is your source, this is your destination, and you have certain paths, certain ways to reach from source to destination. This is one way, this is the second way, this is the third way. Okay. So these are the 3 possible ways. This is your source and this is your destination. So now if you reach from source to destination, you have 3 possible ways. Correct? According to your distance vector protocol, they will compare the number of hops, means the number of routers between source and destination. So if I'm going from source to destination through the path 1, so I have one router and this is the second router. total 2 routers. If I take the second path, only 1. And if I take the third path, 1, 2, and 3. 1, 2, and 3. So if you compare the distance, which is the least distance? Second one. So according to your distance vector protocol, this is the best path. Okay. But this is not always true. Why? It is not mandatory that the shortest path is always the best. Maybe you have a shortcut way, but maybe it is fully damaged. Correct. So what is the possibility that what will happen if, let's say, this is my 100 Mbps link, means this side through this path, I'm having 100 Mbps of speed. Here I'm having 2 Mbps of speed. And here I'm having 1 Gbps of speed. Now tell me, which is the fastest? Third is the fastest? Yes or no? According to this, third is the fastest. So again, if you go with the distance vector protocol, your distance vector protocol is going to send data through this side only. So is it the best way to reach? No, right? So we have the second type, link state. Your link state is going to compare the bandwidth. Now looking at the bandwidth, from the first path, I'm having 100 Mbps. From the second path, I'm having 2 Mbps. And from the third path, we are having 1 Gbps, which is the best. Third path means this is the best. Okay. Then we have the hybrid. Your hybrid protocol, hybrid means it is mixture of two. Okay. It has the features of your distance vector protocol as well as link state protocol. It has the features of both. It is going to compare the distance as well as the bandwidth. Okay. Is it clear? So these are the 3 categories in your IGP. So if we talk about the protocols under your distance vector, your RIP protocol and EIGRP protocols are there, which are the purely distance vector protocol. Okay. RIP not used right now. EIGRP has been enhanced into the hybrid protocol EIGRP. Okay. So this is also not used. In link state, we are having OSPF, very popular protocol, and one is the ISIs. Okay. And in case of hybrid, you have one protocol, that is EIGRP. Okay. In our syllabus, we have only OSPF. But still, I'll be showing you configuration for RIP as well as EIGRP. Okay. And we have will have already seen about the static and default routing. Okay. So today we'll be revising static and default, and I'll be telling you some more ways to configure a static route. And then we'll be going for the RIP, EIGRP, and OSPF. Okay. Then we have the EGP. So EGP is providing communication between different AS, more than 2 AS. 2 or more AS. If you want to communicate, then we go with the EGP protocol. Under the EGP, we have just one protocol, that is BGP, Border Gateway Protocol. Why Border Gateway Protocol? Because it facilitates communication between 2 different borders, 2 different autonomous system borders. Okay. So this is the Border Gateway Protocol. Clear? Yes, sir. Okay. Is it clear? Okay. So today we'll be starting back with the static routing and we'll move to the dynamic routing. So again, your type of routing protocols. We have the static route, we have the default, and the dynamic. Clear? In static routing, we'll have to manually specify a route to the destination network. Okay. And in case of default routing, again, we'll have to manually specify the route. But what is the difference? In case of static routing, we'll have to manually specify destination, the route for each and every destination. Any destination you want to reach, any network you want to reach, you'll have to manually configure a static route. But in case of default route, only one route to all the networks. Then we have the dynamic. Dynamic, we have IGP and EGP. Each IGP has been divided into distance vector, link state, and hybrid. And your EGP is only one category, path vector, and one protocol, that is BGP. Your distance vector protocols are RIP and EIGRP, link state, OSPF and ISIs, and hybrid protocol is EIGRP. This is clear? Okay. Now, theory about your static routing, we have already seen that in your static routing, we will have to manually add all the routes. Okay. So in the last class, we have seen this configuration, right? IP route, network ID, subnet mask, next stop. Correct? Okay. Now, today I'll be showing you some different ways to configure a static route. So first, you can configure recursive static route. Okay. So how do you configure a recursive static route? We have already seen in our last class, that was your recursive static route. Means you give the command IP route, then you give the network ID, then you give the subnet mask, and after that you give the next stop address. This is the way to configure a recursive static route. Now, why do we call it as a recursive static route? Because For reaching the destination network, there is a process happening that is known as recursive lookup. Means your router has to look 2 times into the routing table to reach the destination networks. Why 2 times? Okay, so let's see. Let me configure a static route once and I'll show you why it is happening. So this is R1, this one is R2. Network, we are using 192.168.12.0/24. And this side for loopbacks, I'll be using 2.2.2.2 or say 0/24. Then you can use, or let me just use easy networks like 10, 20, 30. 20.0.0.0/24, 30.0.0.0/24. These are the loopback I'm going to configure on R2. Clear? Now we are going to do the configuration. So one way is you just do the configuration in the router. Second way is you just open your notepad. Okay, with the help of notepad, you can just copy paste. Let's say I want to configure for R1, so I'll say R1. And then what are the commands I'm going to execute? First of all, I'm going to say enable command. Then for global configuration mode, I'll say configure terminal. Correct. After that, I will assign IP. So I'll say interface gigabit 0/0, and I'll say IP address 192.168.12.1.255.255.255.0. And then physical interface, so I'll say no shutdown command. Correct. Okay. This is for R1. Now for R2. So the IPs I'm going to assign here is 12.1, 12.2. So on R2, let me also change the host name of the router. So I'll say host name R1. I'll just copy these commands, paste. So instead of R1, this router is R2, and IP instead of 12.1 is 12.2. Correct. For loopback interface, I'll say interface loopback 1. I'll say IP address 10.0.0.2 because this is second router, so I'll use all IPs 2 only. Okay. Then 255.255.255.0. Let me copy again. 2 more loopbacks are there, so I'll just paste. This is loopback 2. Network is 20. This is loopback 3. Network is 30. Done. Okay. Now what we are going to do, just copy this. Go to the router, go in the user execution mode and paste. Configuration is done. Okay. Similarly, copy the second router configuration. Go to the second router, CLI, go to the user execution mode and say paste. Configuration is done. Here, you can work in the router itself or you can copy paste through the notepad. Okay, this is applicable for both real gears and your softwares. Works in both. Okay. So now if I go to the second router and check the routing table. So I'll say show IP route. So you see I have a route for 10, 20, 30, and 12. So only 4 networks are there, and for all networks, I'm having route in the routing table of R2. Means R2 is able to reach all the networks. Why? First thing you see, they are directly connected. All the network to R2. Correct. So R2 is able to reach, but if I check up on R1, if I check this thing on R1, show IP route. Only one route, only for the network 12 dots. Correct. So what is happening here? It will able to reach only 12.0 network. If I try to ping 10, 20, or 30, it will not be able to ping. Why? Because there is no route in the routing table. So we'll have to add the route. So the first way is your recursive static route. You say IP route, network ID, subnet mask, and next hop address. So let's go and configure it. Go to the global configuration mode and say IP route. Destination is 10. Subnet mask is /24. What will be the next hop value? What will be the next hop value? 12.2. Why? Because we are configuring on R1 and configuring for network 10.0. So router R1 is going to send the data this side. And what is the next hop value here? 12.2. So you're going to say 192.168.12.2. Configure. Okay. Now understand why there will be a recursive lookup or why your router has to check 2 times. So I'll say do show IP route. So if you see, I have a static route and that route is saying if you want to reach 10.0.0/24, you have to go via 12. So now let's say on R1, I'm saying ping 10.0.0.2. Okay. So router, first of all, it is going to check how do I reach 10.2. So it will know from the routing table that, okay, I can reach through 192.168.12.2. It received this thing. But again, how do I reach 12.2? Again, going to check. Okay, there is a 12.0 network. And to reach this, I have to go via the interface, gigabit interface 0/0. Then it is going to forward the packet, because ultimately router has to forward the packet through the interface only. Correct? So it has to know the interface to forward a packet. Okay. So router has to know this interface. So first time your router is going to check for the next hop, and second time it is going to check for the exit interface. Router will check how I'll reach the 10 network through the 12.2 IP. But how do I reach 12.2 also? So it is going to check again, and it is going to find I have to send the data through the packet interface Z0/0. So this is the recursive lookup. Your router is checking 2 times. Your router is looking in the routing table 2 times. So if for one packet, your router has to look 2 times, what if there are a lot of packets? Because in the network only one packet is not traveling. So you can understand the amount of CPU router needs, or router will be using to forward all the packets. The amount of CPU router will be using to forward all the packets. And if it is a big network, there are a lot of number of, there are so many routes, then there will be a problem. Correct? Yes or no? So there is a problem in this recursive static route, that your router has to look in the routing table 2 times. Clear? Understood the problem with this recursive static route? Okay. To overcome this, we have second type of static route. So in here, you can see recursive lookup is the problem. Disadvantage. Second, we have directly connected static route. Okay. So why it is known as directly connected? Because when we are going to configure this route, your router is going to understand, okay, this network is directly connected to me. Okay. So how you are going to configure a directly connected static route? You'll say IP route. Again, you'll say the network ID. Then you'll provide the subnet mask. And you came to know that your router has to get anyhow the exit interface. So why not we provide the exit interface itself? In the routing itself, we provide the exit interface, so router doesn't have to take 2 times, right? So here you directly provide the exit interface. Okay, you directly provide the exit interface, and it becomes your directly connected static route. So how you configure this? So I'm going to configure a directly connected static route. So I'll say IP route for the 20 network. I'll configure 20.0.0.0 subnet mask. This one. So tell me, if router R1 has to reach 20 network, through which interface router R1 has to send the packet? This interface Z0/0. So I'll say you go through Z0/0. Hit enter. Okay. Now if you check the routing table again, do show IP route. So what it is thinking, see your router, what it is thinking, that 20.0.0.0 is directly connected to me. On which interface? Z0/0. Okay. So your router is considering it directly connected. So according to router, your 20 network is connected on the interface Z0/0. But is it actually connected there? No. It is connected after router R2, not directly connected. Okay. So now if you see, when you say in your router R1 ping 20.0.0.2. Okay. So router is going to check how do I reach 20.0.0.2 through the interface. So router will check only once and directly forward the packets through the interface Z0/0. Correct. This is your router R1. This is your R2. This is Z0/0. 12.1, 12.2, R2, R1. This side you have 10.0.0.2, 20.0.0.2, and 30.0.0. This is it. Okay. So your router consider that your this particular network, it is directly connected on the interface Z0/0. So it will send directly packets here. If you say the command ping 20.0.0.2, it will check, okay, Z0/0, forward this side. But this side, it is not going to find it. Why? Because there is a different router. So if your router R2, if it works as a proxy, then your router R2 is going to give its own MAC address. Then you will be able to communicate. But what if it is not acting as a proxy? Router R2 is not going to give you the MAC address. And if it is not going to give the MAC address, will you be able to communicate? No. So in case of directly connected static route, your proxy ARP is a disadvantage, Means if your router, if it is acting as a proxy, then you'll be able to use, otherwise your static route will not work. See, right now if you see, so in your routers, your proxy ARP is by default enabled. Okay. So right now, if I try to ping 20002, okay, do ping. I'm able to ping. Why? Because if you check the ARP, do show ARP. So for 20002, what is the MAC address? 9401. Let me show you. This is the MAC address of this router interface. Router R2 interface. Show interface Z0/0. Means your router is acting as a proxy. But what if it stops acting as a proxy? What is going to happen? So let me do one thing. I'll go to this interface and I'll say no IP proxy ARP. And I'll stop it from acting as a proxy. Now your router is not going to act as a proxy. So will I be able to communicate? No? Let's try. Because it has already recorded the MAC address. R1, we did the communication first time, right? So it has entry in the ARP table. So either you wait 4 hours so that this particular ARP entry vanishes. Or if I clear this ARP cache. So let me go to the interface Z0/0, shut, no shut. And now let me check, do show ARP, not having the ARP. And if I try to ping now, do ping 20002. So your R2 is not going to give the MAC address now. Why? Because it is not acting as a proxy. And you see, you are not able to communicate. Okay. So this is the problem with your second type, the directly connected static route. In directly connected static route, your proxy ARP is the problem. Okay. And as soon as I go and configure it back, I make R2 work as a proxy. Instead of no IP proxy ARP, if I say IP proxy ARP on the interface Z0/0, it is going to work as a proxy. And as soon as your R2 is working as a proxy, your R1 will be able to communicate with 20002 because R2 is going to provide its own MAC address. This is clear? Okay.
Sure.
Yes.
So if the R1 and R2 are both connected by G0/0 port, if the R1 is connected by G0/0 and R2 is connected by G0/1, if this the cable will be valid?
No, there will be no issue. See, doesn't matter which interface you are connecting. This doesn't matter. Interface number should not be same. It can be Z0/1, Z0/2. They are still going to communicate. Okay, this is not an issue. This is clear. So again, our first type is also having some problem. Second type is also having some problem. In first type, your recursive lookup is a problem. And in second type, your proxy ARP is a disadvantage. So we came up with the third idea, fully specified static route. This is the third type. So what was happening? In case of recursive static route, your recursive lookup is a problem, but proxy ARP is not a problem. Okay. And in case of directly connected, your recursive lookup is not a problem, but your proxy ARP is a problem. So means whatever problem is there in the recursive, that is overcome by directly connected, and whatever problem is there in the directly connected, that is overcome by recursive. So why not we specify next hop as well as exit interface both? So due to next hop, we will not have proxy ARP issue, and due to exit interface, we will not have recursive lookup problem. Okay. So how do you configure it? You say IP route, network ID, and then you provide the subnet mask. Then you provide the exit interface so that recursive lookup is not a problem. And then you provide the next hop. And this is the best way to configure. This is the best way to configure a static route. Means no recursive lookup problem, no proxy ARP issue. Okay. And this particular third type, it will not work in your packet tracer. Your packet tracer doesn't support this. And one more thing you need to remember is your exit interface will always come first, then your next hop will come. If you write next hop first and then try to give exit interface, this will give syntax error. Means this command is not going to work. Your router will give you an error. So your exit interface will always be first and next hop will be after that. Clear? So if you try this in your packet tracer, it is not going to work because your packet tracer does not support. If I go on R1, and if I try to configure IP route, let's say 30.0.0.0, 255.255.255.0, Then if I give the exit interface 0 by 0, and if I check if I can write anything else, so I can just write the metric. I cannot write the next stop value. And if I write the next stop address, let's say 192.168.12.2, then there is no option to write the exit interface. So in your packet tracer, it is not going to support. So this one practical we are going to do in the GNS3, but in real routers, it is going to work. Okay. Just as it is the limitation of your packet tracer that we cannot perform this practical in. Okay. So for this one practical, I'll be using GNS3. In GNS3, you use the real router IOS. Okay, works like a real router only. Same command line access you get. Okay. So these are the two routers, R1 and R2. Okay. And let me change this according to our topology. 10.0.0.0, 20.0.0.0. Correct. And here we have 12.1. This side we have 12.2. Okay, so these are the two routers. We have R1 this side and R2 this side. This is R1, and this side we have R2. So if I check the IP addresses on R1, so I'll say show IP interface brief. So no IP is assigned, and the interfaces are fast Ethernet, not the gigabit on these routers. So if you see here, which interface is this side? Fast Ethernet 0/0, and this side also fast Ethernet. Okay. So on fast Ethernet of R1, I'm going to assign. So I'll say configure terminal interface F0 by 0. I'll say IP address 192.168.12.1, 255.255.255.0, and no shutdown. This interface is up. Okay. Interface is up. Even the same configuration, you can just copy paste. See, instead of instead of gigabit, I'll say fast Ethernet, and I'll just copy. And same thing you can do in all your softwares. Done. Okay. So this copy paste.
What is the command for paste?
Right click. For terminal in your real routers and in your GNS3 and other terminals, it will be right click. You just paste with a right click. Okay. Okay. If you check the IP addresses now, do show IP interface brief. I have the IP 12.2 as well as I have all three loopbacks. Correct. Then if I check in here, do show IP interface brief. I have the IP. So now on R1, I'm going to specify fully specified route. Okay. Global configuration mode. I'm going to say IP route. Let's say I'm configuring for 10 networks. So 10.0.0.0, you'll give the subnet mask. Then we have to give the exit interface. So what will be the exit interface? Fast Ethernet 0/0, F0 by 0, F0 by 0. Now, if I give the question mark, you'll see forwarding router's address means next stop value. So if I give the next stop value 192.168.12.2, this is the next stop value. Okay. But what if I try to say 192.168.12.2? And then if I check, there is no way to configure an exit interface. So your exit interface will always be coming first, and then your next stop will be coming. So you'll say F0 by 0, and then 192.168.12.2. This is clear. Now, if you say enter, and if you check the routing table, show IP route, and if you say the command ping 10.0.0.2 on your R2, so your R2 is going to check the routing table that to reach the 10 network, I have to go via 12.2, and for 12.2, I have to go via. So no need to check again. In first check only, it knows, okay, 12.2, and I have to exit through fast Ethernet 0/0. Now I can directly reach. You can say ping 10.0.0.2. You have the connectivity. Is it clear? Any doubt? No? So these are the three ways to configure static route. Clear? Okay. So any doubt with this part? Static route? Okay.
If you are using this application, so is there any way that you can trace the packet?
Yes, you can. That is the Wireshark. In this, like in your packet tracer, we use the simulation mode. In GNS3, you are going to use your Wireshark.
Go to a different application or from this itself?
When you install the GNS3, your Wireshark gets installed along with this.
What configuration of laptop required?
8 GB is sufficient. i5 and 8 GB more than good. See, if you right click on this, right now it is not on. Yeah, you see the start capture. If you click on start capture, it is going to open your Wireshark. Okay, because right now there is no running device. Let me start them and let's see. It is going to open your Wireshark, the Wireshark network analyzer. Okay. And it is going to start capturing the packets. Right now, there is no configuration running in these routers, so nothing is happening.
Same as simulation.
Yes, much better than that. You get more information in the Wireshark because, like your Wireshark, it is actually network analyzer. Okay, it gives you all the information about all the layers in detail. So this is clear, the 3 ways to configure a static route. Any doubt in this part? No? Then default route we have already discussed. So there is no other way to configure the default route. This is only one thing. Okay. And after that we have RIP. So if we discuss about RIP, your RIP stands for Routing Information Protocol. Okay. It is a purely distance vector protocol. Your RIP, it is a purely distance vector protocol. And there are 2 versions of RIP. One is the RIP version 1 and RIP version 2. What are the differences? Version 1 and version 2. First of all, it is classful. And this is classless. Okay. Second, it does not support VLSM. It supports VLSM. Okay. It does not support VLSM and it supports VLSM. Does not support authentication. Supports authentication. Then your RIP version 1. It is broadcasting its routing updates on the address 255.255.255.255. Means for sharing the routing updates, because what happens in the dynamic routing protocols, the routers talk to each other and they share that, okay, this network is connected to me and you tell yours. So they share the information with each other that I know about this and you know about this. Okay. So for sharing the information, your RIP version 1 uses a broadcast message while your RIP version 2 uses a multicast. Your RIP version 2 uses multicast 224009. This is the multicast address used by the RIP for exchanging the routing updates. Okay, so these are some differences between your RIP version and version 2. So same thing is there. It is classful, uses broadcast. Version 2 is classless, uses multicast. It is a distance vector protocol. Now it uses a hop count metric for comparing the path. For comparing the path, your RIP uses hop count. Means it calculates the number of routers between source and destination. And the path with the least hop count will be the best path. And your RIP has hop count limit of 15. Means if there is a network beyond 16 hops, your RIP will not be able to reach there. That is totally unreachable. Okay. The algorithm your RIP uses is the Bellman-Ford algorithm for the distance calculation. Okay. Then it works on port number 520. Your RIP uses the multicast address about RIP version 2. Okay. Not the RIP. This is RIP version 2. RIP version 1 uses broadcast. Then AD value, administrative distance value of RIP is 120. And then there are certain timers in your RIP: hello timer, invalid, hold on, and plus timer. So what are these timers? Because these 2 routers, they'll be talking to each other and sharing information, right? But what if the information doesn't arrive in time? Your router 2 is going to wait for some time. So they will be sending hello packets every 30 seconds. Means this router is going to say hello and it is going to repeat with the hello. So if they are communicating every 30 seconds, that means both routers are up and working. But if due to any reason R1 doesn't receive the hello from R2, so how long it is going to wait? How long it is going to wait? So that is your invalid timer. If still in 180 seconds, it doesn't receive any update, it will say that, okay, I'll wait some more time. But if a hello comes also, I'll not receive it. In the hold down timer, your router doesn't receive any new update. It will not accept any new update. And then it will flush the routes, all the information delivered by R2, it is going to flush out, and then new information will be taken. Okay, these are the timers. So total 240 seconds your RIP takes to retake a route.
So, explain the hold on thing.
Yes, see what happens exactly. First is the hello timer. They'll be sending hello packets to each other that, okay, I'm available. Okay, kind of keep alive that, okay, I'm alive. Then if still in 30 seconds, there is no update, it is going to wait for some time before declaring the route as an invalid. Okay, before declaring the route as an invalid. So it is going to wait for 180 seconds. Okay, let's say still update not received. Now, what if the update is coming from somewhere else? Because see what happens. If there are more routers, the routers are going to have information. So all routers, other routers will also be delivering the information that I know how to reach. Correct? For example, just take an example of the 10 network. Okay. So for this 10 network, they are going to deliver the information that your router R2 will say, okay, I know how to reach. And if these are connected like this, so R3 is also going to say, okay, I know how to reach R2. I know how to reach R2. But if R2 is down, what will happen? So your R1 is not going to receive any update regarding 10 during the hold down time. It will say that I know this is invalid. So now I have already declared it invalid. I'm not going to receive any update for some time.
Even though the R2 is alive.
R2 is not alive.
So in that meantime, if the R2 came alive, then the communication
still in hold on. It is still in the hold on period. So it will not accept. First of all, it is going to flush out the information. Then it is going to retake the information from a new end, beginning. Clear? So this is the RIP. Now, how do you configure RIP? In the same lab, let's do the practical. So again, for these three routes, for the three networks, we have configured the static route. Now, instead of static, we are going to configure RIP. So let me remove the routes. Do show. So these are the routes we configured. 2 routes. I'll just copy them. Go to the notepad. Paste. I'll say no. No. Again, copy. Instead of typing everything, you can do your work more easily and just say paste. Good. Okay. So whatever command you gave to configure the route, just say append a no in front of it, and it will be undone. Okay. Okay. Right now we do not have any route. You can check do show IP route. There's no route in the routing table of R1. So to configure RIP, how we are going to configure the RIP? See here. In the global configuration mode, you are going to say router RIP. Okay, router RIP. Now RIP version 1 we are not going to use because it is a broadcast and it is classless, so it does not support subnetting. Okay. Now to configure version 2, you will say version 2. After that, you are going to say network, and then you are going to provide directly connected network ID. Okay, you are going to provide here network ID, and this network ID is directly connected. Okay, not the destination. This is the directly connected. Okay, this is not the destination network. This is directly connected network. So tell me, if I configure on R1, which network is directly connected to R1? Only 12.0. Correct. So on R1, I'll just configure and say router RIP. I'll say version 2. And in the network, I'll say 192.168.12.0. That's it. Done configuration. This is all the configuration we need for R1. On R2, we'll go to R2. So on R2, how many networks connected? I'll say router RIP. Then I'll say version 2, or in short, V2. And then after that, what are the networks connected? First is 192.168.12.0. Correct. Second, 10.0.0.0. Third, 20, fourth, 30. This is all the configuration for R2. Now these two routers will automatically contact to each other, communicate with each other, and they'll decide what is the best route. So now if I go to R1 and check the routing table, before it was not having any route, only one route was there. And now if I check again, do show IP route. Okay. What is the routing protocol code? R. R means RIP. These routes have been learned via RIP. To reach 10.0.0.0/8, we have to go via also the exit interface. So will there be any recursive lookup or Proxy ARP issue? No. Similar way, 20 and 30.
This will automatically take the interface also.
Everything automatic. Okay. This is the benefit of the dynamic routing protocols, that you don't have to do any calculation, configuration, nothing. They'll do by themselves. You just have to tell the routers about the protocol as well as the networks connected to that router. That's it. Rest of the task will be done by your protocol. Okay. Is it clear? And now this is your RIP version 2, right? So the routers will be communicating with each other via multicast. Correct? So let's see the multicast also. I'll just, okay, this update has come. 224009. Is it clear? See, RIP version 2 and port number 520. Clear? And you can see what network information they are exchanging. Clear? So RIP is clear. Any doubt with the RIP? No. So let's go for the next protocol. That is your EIGRP, Enhanced Interior Gateway Routing Protocol. Before we were having the IGRP protocol, right? IGRP was Interior Gateway Routing Protocol. Okay, purely distance vector. So again, distance vector was having the problems. Only hop count metric, Bellman-Ford algorithm. Okay, and also was using the broadcast address to multicast to exchange the routing updates. So there were certain problems related to distance vector. So it was enhanced and a new protocol was created, EIGRP. Okay. Your EIGRP, it was in the beginning your Cisco proprietary protocol working in the Cisco devices only. But now it has been declared open standard. So it can be used in all other vendors also. Your EIGRP is a link state as well as distance vector protocol. It has features of both link state and distance vector. So it is known as hybrid protocol. Clear? Protocol number of EIGRP is 88 and it uses 2 AD values. Your EIGRP uses 2 administrative distance values, one for internal routes and second for external routes. Okay. For internal routes, it is 90 and for external routes, it is 170. Okay. Now your RIP has the metric hop count, only one metric, but your EIGRP has certain metric values, 5, total in 5. In total, 5 metric values, they are K1, K2, K3, K4, and K5. Means it uses a bandwidth metric, load, delay, reliability, and MTU. These are the 5 matrices your router uses. I mean, your EIGRP protocol uses. Okay. Now, see, by default, your EIGRP is going to use bandwidth and delay only. It is not going to use these 3. But you can configure the EIGRP in such a way that it will use all 5. That is up to you. But by default, it will always be using just the bandwidth and delay. Is it clear? Okay. To exchange the routing updates, your EIGRP is going to use the multicast address 2240010. So 224009 is the RIP and 10 is the EIGRP. Your RIP was having certain timers, but your EIGRP has only 2 timers, hello and dad. Not actually dad. In routers, you'll find it with the name hold time. Okay. In routers, you'll find this as a hold time. So hello is 5 seconds and hold time is 15 seconds. So if there is no update in the 15 seconds, that route is flushed out. That's it. Then your EIGRP have 5 packet types. One is the hello, acknowledgement, update, query, and reply. So hello packet is a keep alive packet. It is used to discover the routers and maintain a neighbor relationship. This is why your hello packets are used. Okay. Now, once they have become neighbors, they are going to send updates, routing updates to each other. They'll say, okay, I know about these networks. And the other router will say, okay, I know about these networks. Now, let's say these are the 2 routers, R1 and R2. First of all, they are going to send hello. It is going to say hello and it is going to say hello. And finally, they'll become the neighbors because they both are neighbors, right? Then it is going to say, these are the networks I know. And R2 is going to say, okay, these are the networks I know. And before that, your R1 is going to say, okay, I received, acknowledge. It will say, okay, I have received your update. Then it is also going to send update. Your R1 is going to say, okay, I have received your update. Now, R1 sends some routes to R2. In those routes, if R2 is not having some information about a particular network, R2 is going to say, I want more information. Query. Okay. It is going to ask for a query that I want more information. And R1 is going to reply with the help of a reply packet. Is it clear? These are the 5 packet types. Okay. And for each query, update, and reply, there will be an acknowledgement. confirmation that, okay, I received your query, I received your reply, I received your update. Is it clear?
Hello packet is going to multicast address.
Hello packet is going to multicast address.
Sir, do you understand concept of multicast?
Multicast is all these packets will be traveling, right? They'll be traveling on the multicast address only.
That particular address
Reserved. Class D. Completely reserved for multicast.
used to means share the information.
Yes.
That particular IP.
They use this particular IP to send the information to all the routers. Any router who is joining or listening on this address will be able to listen to that message.
You have mentioned earlier studying IP address, you said this is reserved for multicast.
Yes. This is class D, completely reserved for this only. Okay. And you see all the addresses are starting with the 224. Okay. All right. So now let's configure the EIGRP. So for EIGRP configuration, EIGRP is a very big protocol. Okay. But I'm just showing you the basic. More detail in the CCNA. So same like your RIP, you are going to say router EIGRP. But in case of EIGRP, you will have to provide ASN value. Okay. This ASN value ranges from 1 till 65,535. What is ASN? Autonomous system number. Autonomous system, we understand. Autonomous system, we understand that number of routers configured and managed by a single organization, like a branch. That is going to be a ASN. But how do you identify the ASN? With a number. With a number. So each and every organization that is maintaining organizing some number of routers, they are having a ASN value. Okay, like popular companies, you can take your Airtel, Zio, all these companies, all your ISPs. So you can check. You can say like in your Airtel ASN, and you see it is having the ASN number 9498. This is the ASN number for Airtel. Similarly, all organizations that are maintaining some routers, they are having an ASN value. So this AS value we have to provide. Okay. Understood? After that, you are going to say network, and then again network ID that is directly connected. After the network ID, in case of EIGRP, you have to provide the wildcard mask. Now, what is a wildcard mask? Although it is not mandatory, but still you can provide. It is totally optional, but still you can provide if you are using subnetting concept. Okay. So what is wildcard? Understand. /24. What is the subnet mask? Correct. So let's say you are using a network that is having this subnet mask /24 network. Like your 10.0.0.0 we have used is having /24, right? But instead of subnet mask, we have to write here wildcard mask. So how do you calculate wildcard? Simply understand. So out of 4 times 255, just subtract your subnet mask. What is the subnet mask? This is your subnet mask, right? And you will get your wildcard mask. What will be the wildcard? This is the wildcard mask. Subtract your subnet mask from 4 times 255, you will get your wildcard mask. Okay.
16, then it would be 0.0 from 255 to 255.
What?
If the subnet mask is 16.
Subnet mask is?
Sorry, if the subnet mask is flat fee, then
16 you're talking about. Yes, 0.0255255. This is just a simple way. Out of 4 times 255, subtract your subnet mask, you get the wildcard mask. Okay. Okay, so let's go and configure. Now we have configured RIP on R1, right? To remove the configuration, very simple. No router RIP. That's it. All configuration gone. Okay. Similarly, go to R2.
So it doesn't even ask for like reconfiguration, right?
No. As soon as you say no router RIP, that's gone. No confirmation. Okay. Go to R1. Configure EIGRP. So we'll say router EIGRP, and you can see it is from 1 till 65,535. You can use any number. Let's say I'm using 1. But one thing need to be noted that this ASN value should be same on all the routers. On R1 also this should be 1, then on R2 also it should be 1. So choose any value, but it should be same on all the routers. Okay. Then say network, only one network connected to 192.168.12.0. This is the wildcard 000.255. Hit enter, configuration done. Go to R2. Router EIGRP 1 network 1 is the 192.168.12.0 000.255. You see they already become neighbor because they are having this common network, right? So as soon as I configure this common network on both of them, they are becoming neighbors. Network 10.0.0.0.0.0.255 because /24. For 20 we configured, for 30 we configured. Configuration is done. Okay. Now go and check on R1. We'll be having the routes. Show IP route. We are having the routes. What is the routing protocol code? D. And D means. Now there's a small homework for you. Why this is D? Why not E? For static we have S. For RIP we have R. For OSPF we have O. Then why not E for EIGRP? Why is it D? Distance vector. RIP is your distance vector. This is hybrid, then it should be H. Correct? Okay, so this is your homework. Why not D? I mean, why not E? Why is it D? Okay. Okay, now if you see here, for 10 network, what is the administrative distance value? 90. How we are going to reach? 12.2. And how 12.2? Interface Z 0/0. Similarly for 20, similarly for 30. We are having the routes. Clear? EIGRP configuration, any doubt? Online people?
No.
Okay. Any doubt with this? So clear? Next we have OSPF. Your OSPF stands for Open Shortest Path First. So why the name is OSPF? Because it is an open standard protocol, first of all. And it uses Dijkstra's shortest path first algorithm, SPF algorithm. So open shortest path first. This is the name. Okay. So it is a linked state protocol, works on the protocol number 89. AD value only one is using, so that is 110. Unlike your EIGRP is using 90 and 170. Okay. Now your OSPF uses 2 multicast addresses. All other protocols, they are using 1 multicast. Your OSPF is using 2 multicast addresses. One is the 224.0.0.5, one is the 224.0.0.6. Okay, and I think I haven't shown you the multicast address for EIGRP. So you can check. This is the packet. Destination is 224.0.0.10. Okay. So your OSPF uses 2 multicast addresses. One is the 224.0.0.5 and second is the 224.0.0.6. 224.0.0.5 it uses when it is sending the traffic for all OSPF routers. When the traffic is going for all the OSPF routers, it will be going to the multicast address 224.0.0.5. And when it is going for DR and BDR, this is a concept in your OSPF, DR, BDR. So when any traffic is going for the DR or BDR, it will be going to the multicast address 224.0.0.6. So normally your OSPF will be working on this, but if there is a DR, BDR, so there will be using 224.0.0.6. The 224.0.0.6 traffic, it will only reach the DR and BDR. It will not go to other routers. Okay. So this will be understanding when we are understanding the concept about DR, BDR, and I'm going to show you how you are going to configure DR and BDR. Works on Dijkstra's algorithm. OSPF uses areas. What is an area? So if you see, your EIGRP uses autonomous systems. And your OSPF is also an IGP protocol, means it is going to provide communication between the same AS. In one AS, it is going to provide communication. But what if in one AS there are a lot of routers? So if the routing update is going from one router, let's say there are 100 routers. So from 1 to 100, if it is reaching, and each and every router in the way is processing that packet, it is going to create delay. It is going to create delay. So for faster convergence, your OSPF, what it does, it divides that autonomous system into smaller areas. Means dividing a autonomous system into smaller parts, and those smaller parts are known as area. Now, each and every area routers, let's say there are certain routers. This is one autonomous system. And there are certain areas OSPF has divided. Let's say 2 areas. So if there are some routers in this area, they are going to have the information about this area only. If there are certain routers in this area, they are going to have information about this particular area only. Now, if you want communication between these 2 different areas, you are going to need a special type of router that is going to be known as ABR, area border router. That is going to connect 2 borders, the borders of 2 areas. Okay, so that is going to be ABR. For an area to be an ABR, one area always must be 0. And other area can be anything. Let's say area 1. Why? Because this area 0 is known as the backbone area. In your OSPF, this is known as backbone area. But right now, we do not need to discuss about these details. Okay. So right now, you just understand your OSPF uses the area concept to divide an autonomous system into smaller parts. Why? For faster convergence. So that if the routers are in one area, they will be having information about this area only. So they will converge faster. They'll send the updates faster. Okay. For communication between 2 different areas, we are going to need a special type of router, that is ABR, area border router. Okay. Then it uses the process IDs. Okay, like your EIGRP router, EIGRP, we say 1. That is 1 is your ASN. But in case of your OSPF, that will be process ID. And this process ID need not to be same on all routers. Doesn't need to be same. You can use any process ID on any router. Up to you. Clear? Then OSPF uses DR and BDR concept. This will be discussing. It is used in the multi-access network. And it is classless, so it supports VLSM and CIDR. Means support subnetting. Okay, so only your RIP version 1 doesn't support subnetting. Otherwise, your OSPF, ISIS, EIGRP, BGP, everything all supports VLSM and CIDR, or you can just subnetting. Is it clear? Any doubt? Okay. So basic configuration of OSPF, I'll show you. Then tomorrow we have to discuss it in detail, the OSPF. So to configure OSPF, we are going to say router, OSPF, and the process ID. Okay. Then you are going to say network and the directly connected network ID. In all your dynamic routing protocols, you will be providing only directly connected networks. Okay. So we'll say network ID and wildcard. And after that, you are going to say area and area ID, means to which area this belongs. Okay. So when you are designing a network in case of your OSPF, let's say same network we are designing. So this particular network will be in some kind of area. We have to specify an area value. So we'll say, let's say this is your area 0. So now the entire network is in area 0. So how you are going to configure? Go to R1, configure terminal, no router EIGRP. 1. Done. Configure OSPF, router, OSPF, and process ID. Anything you can take, again the same values. So I'll take 1 only. Then you say network. The network directly connected is 12.0. Wildcard. Area 0. You see, holding time expired. Why? Because we removed the EIGRP configuration from R1, right? So I'll say no router EIGRP 1. Then router OSPF 1. Network 192. I'll configure it at last because it will become neighbor also. 000 255 area 0, 20, 30, network 192.168.12.0, area 0, and you'll see they will become neighbors. Became neighbors, you received the masses. Okay. Check the routes on R1. Correct. What is the AD value? 110. Okay. And have routes and you have the connectivity. 10.0.0.2, 20.0.0.2, and 30.0.0.2. Clear? Any doubt? Online people? Any doubt with this thing? Or is it clear?
Yes.
Okay. So this is how you can configure EIGRP, OSPF, RIP, static routing, and default routing. This is clear. Tomorrow we'll be discussing OSPF again and in detail. Okay. Because we have certain more concept to discuss. But if I discuss today, it will be a lot of information for one day. Because like static, default, then RIP, EIGRP, and OSPF, it is already a lot of information. So today you guys practice, and tomorrow we'll be starting with OSPF again. Okay, because we have to discuss about neighbor states, packet types, then we have the DRBDR election, we have the router ID, many more technical ones.
What is the most running of this protocol?
You can use OSPF, EIGRP, up to you. Network admins decide accordingly. According to your facility, you decide because you are the one you are going to configure the network. Okay, but mainly OSPF is coming in use. Because like in other vendors, if you talk in your Juniper, still your EIGRP is not there. So OSPF is the choice. Okay, and that's why we'll be discussing OSPF in detail. Okay, any doubts so far?
Do you share the PowerPoint slides as well in the cloud?
Which slide?
The slides, these slides.
Yes, I'll be sharing.
Okay.
Oh. Any more doubts? No? Online people?
No, Ajay.
Okay, guys. All right, then we'll meet tomorrow. Have a great day, guys.
Thanks, Ajay.
Okay, thank you.